Okie doke. So, law of science is a kind of like a companion to right triangle, trig, and Pythagorean theorem. They all do the same thing. They find missing parts of triangles, but the beauty is it doesn't have to be right triangles. So, I am going to tell you, here is the law of science. But then we're going to prove what the heck, where it comes from, right? The most important thing you need to understand is, in order to even use it, is the letters and what they refer to, okay? The ratio of a side to the angle across from it. So when I say little a, then capital A is the angle across from that side. Those are pairs. The side and the angle across from it. Likewise, little c represents a side, and big C represents the angle across from it. And big B is the angle, little b is the side. You follow me? So it's all about the side and the angle across from it. That actually makes sense. That's the biggest relationship. An angle makes a side across from it large or small based on how big the angle is. I'll come back to the Greek letters in a second, but let's prove. What the heck? Where does this come from? So would you draw me a triangle? And we're just going to focus on C, A, big A, and big C, all right? We'll leave B out of it for the time being. Okay, now, in order to get this idea rolling, or where this idea came from is, like you've been doing in the homework, somebody said, well, what happens if we draw that? So draw in your height, should be the right angle. And let's talk some trigonometry, shall we? Based on this triangle in blue, what trig is implied? You have an angle, the side across from it or opposite it, and hypotenuse. So what trig? Sine. Way to go. It's the law of sine. So that was a great guess. So by law of sines, sine of capital A, angle A equals opposite H over small side C. Remember, capitals are angles, lowercase are sides. You follow me? That's pretty super special, but also would you look at this here? Triangle over here in yellow. Okay? Talk some trig to me now, people. Sine of capital C equals opposite angle, opposite side H over hypotenuse A. Right? Now, all that's wonderful. Now the question is, how do they relate? Well, what one thing do they have in common? H. They both have H in common. H is equal to A sine C. That's big C. And H is equal to C sine A. Well, if they both equal H, then they must both equal each other. So it must be the case that C sine A equals A sine big C. Now that's nice, but it's not very pretty or clean and hard to remember. So instead we put sides and angles together that form a pair. So if you divide C over, then sine of big C over side little c, and divide little a over sine of big A over little a, we get the idea that there is consistency between, no matter what in the triangle, the ratio of the sine of an angle to the opposite side is the same for all three sides and angles. So you could say similar to B. We could bring B in by drawing a different height, but we usually don't show all three. Similar to B, so on. All right? Now, the textbook, Saxon's textbooks usually writes it with the sign on bottom. Every book I'm used to and the SAT puts signs on top. So just so you're clear, it's the same either way. I can take reciprocals, but it's the same. It's the same idea. You with me so far? All right. Greek letters. Also, if you take this class on a college level, this is a pretty common first class in college, you wouldn't use A, B, and C. Instead of angle A, they would use a Greek lowercase a, which is alpha. Instead of angle B, they would use a lowercase b, which is like a big B with a tail. Beta. And what's Greek C? Exactly. Greek C doesn't really have a companion. It's the third letter in the Greek alphabet, and that's gamma. It looks like this. Think of it like a, I don't know what. Okay? So I'm going to show you that again. So first of all, it usually has a tail at the start. So do that. And then kind of a Y, but more symmetric, not pushed to a side. Yeah? That is gamma. Alpha, beta, gamma is the alphabet. It starts gamma. Right? In uppercase, it's like a little hangman sign. All right. At any rate, let's talk about when to use this. There is a law of signs, and you'll do a law of cosines, and you're going to have to know, oh, in this case I use that one, and in that case maybe this one. You use a law of signs anytime you have a pair. Where pair means a side and the angle across from it is known. Across from it is known. That constitutes a pair. So, for example, in this case, in A, do you have a side and an angle across from it given in any case? Do you know any of the angles? Talk to me, people. No. No. So this is not law of signs. You could not use law of signs here. No matter what of the three ratios you did, 4 over sine C, 5 over sine A, 7 over sine B, you'd have two unknowns. It would never pan out because two unknowns in one equation. All right. In a case like this, you have, in terms of what's together, you have 5 and A go together. C and this side, who I don't know, go together. And 71 and 7. Now those go together. Now that is a pair. I know the angle and the side across from it, so this is a law of signs case because a pair is given. Or no. You follow? Would you do the other three then on your own? Tell me yes, law of signs, or no, not law of signs on your own.
Wait, so the side, like if the side is known, but the angle is not, it's still not one?
If they're anywhere in the triangle, in any one case, there is a side and the angle across from it is known, then you're good to go. And it doesn't have to be all three. So in this case, the fact that I didn't know 5 and A, that didn't stop me, because I did know there was a case where at least once I had both, the angle and the side.
You just have to have both.
As long as you have one case where there's the angle and the side, you're good to go. So side C, yes, you do have a pair, or, sorry, triangle C, yes or no? No, not left side. All right, sounds like you have an idea. Keep going. If you're confused, I'll be walking around. You're good? All right, what about D? Yes or no? Yes. In D, what side and angle are known? 62 and, uh-oh, don't know it. So no. What else? That's the only angle you know. So is that okay or no? No. No. Okay. What about E? You have 100, but you don't know B, so that's a no. You have 42, but you don't know C, so that's a no. And you have 12, but you don't know A, so that's a no.
Not yet. Yeah.
142.
Oh, what? So you're saying because you can't find A? All right, so you could find A, 5, triangle sum conjecture, then is law of signs okay? So that is actually yes. Because although you don't have everything given, you have a way to get it. All right, now let's talk about using it. 2 cases, and we'll maybe get some of the homework done, and we'll see how it goes. So, in this case, first and foremost, ask, is it applicable? All right, so it is applicable because you do have a pair that's 7 and 23 degrees. All right, so now, you would first say, is it law of signs? Later on, that'll be more important as you have law of sines and cosines. It is, it's okay. We have a pair. All right. Next is you set up your 3 ratios. All right. So in the law of sines, it's the side is to the sine of the angle across from it. So 7 is to sine of 23 degrees as or equals the ratio of. What else can you give me? Give me another ratio. 10 is to the sine of A as little b is to the sine of big B. All right. Now, in solving, you choose 2 ratios, so there's only one unknown. So I certainly wouldn't be using this b sine of b because I've got 2 unknowns there. That's too much unknown. Instead, I use those 2 guys, yeah? And when I choose, after I choose, I solve or cross multiply, right? So the cross product is 7 sine of A equals 10 sine of 23. Do you see where I'm coming from? Okay? Then I want to get the angle A by itself. I have 2 things with the angle A. What do I get rid of first? 7 sine of A is 10 sine of 23 over 7. And then A is the inverse sine of 10 sine of 23 over 7. And that is, that's where your calculator comes in. You will need a calculator. What'd you get? Do-do-do. Do-do-do-do-do. Inverse sine of 10 sine 23 over 7? 33 point blobbity blobbity blue. Give me 3 decimals, say it again. 33.5.
9. No, 9 instead of 5.
925?
No, 9 instead of 5.
What? You said 5.
No.
Why are you such a liar? 9?
33,9305.
9305. Okie dokie. All right, cool. That's degrees. Put units on it. All right. In terms of answering the question, they asked for angle A, we found angle A. What else do they ask for? Side B. Okay. So side B, how will I find side B? Pythagorean theorem. The only problem with that is it's not a right triangle. So Pythagorean theorem is out. What else?
Trying to find the angle.
Okay. So to find side B, we actually have to find angle B, or sorry, angle B first. How do we find angle B? 180 minus 23 minus angle A. You follow me? So 180 minus 23 minus angle A is something obtuse-ish, I hope, yes? Come on, baby. All right, and oops. Now, I guess I should just use you guys. I'm gonna have you guys do it for me. So, report your answer again. 156. So 120 what? Point 0695. Okay, cool. Now let's find little side B. How do I do it? Okay, so if I take this ratio, now that I know angle B, I can use the allowed signs again. So give me my cross product. When I use this with the original ratio, what do I get? 7 sine big B equals, I cross multiplied, 7 sine big B equals little b sine 23, yay? So little b then is 7 sine of big B, which we just found using our answer button, divided by sine of 23. Make sure you use the answer button and carry over your answer exactly, not rounded numbers. Never round in the middle of a problem. Otherwise, your answer will have propagated error. So what did you get if you use the answer button? You know where the answer button is? Are we good? Is that something you know how to do? Okay, cool. Okay, so to recall an answer, it's right there. What did you get? Alrighty. Somebody, so we can move on with our life. 15.013. Is that degrees or no? That's the length. That's the length. All right. Does it make sense that the longest side is across from the biggest angle? Yeah, that should always be the case. The biggest side across from the biggest angle, smallest side across from the smallest angle, and so on. All right. There is one wacky point, though. Sometimes when your calculator will lie to you, so call this a calculator lying case. Here is the triangle, and is it a law of signs case? Yes or no? Why? So you have a pair. You agree an angle on the side across from it is given, so it is law of signs case. Now give me the ratios. Give me one ratio, Katie. Katie. Okay. To what? Oh, sorry. This Katie. Very good. Sorry. No wonder you're confused. Okay, A over. Go ahead. A over. Sine of angle A. All right, that's cool. Katie, give me another ratio.
20 over sine angle C.
Right. Give me a third ratio. Megan?
7.7.
Perfect. All right. Excellent. All right. So we got 3. Which 2 do I take at a time? Do I take 1 and 2, 1 and 3, or 2 and 3? 2 and 3. 1 has way too many unknowns. I want to take 2 and 3. If I take 2 and 3, by cross product, I would get something like 7.7 sine of big C equals 20 sine of 21.55. Yay? Sine of big C then is 20 sine of 21.55. So angle C is 20 sine of 21.55 divided by 7.7, and then how did I get rid of the sign? Inverse sine. All right, so the inverse sine of that. Would you throw that in your calculator? Inverse sine of 20 sine 21.55. Inverse sine is in the trig menu. Oops. Of 20 sine. I'm in radians, so I'm going to have a problem. I'll have to fix that in a minute. Divided by 7.7. And you. Settings. Dang it. What did you get in degrees? Sorry. 80 divided by pi. 6 point, sorry, say it again? 72 point, what is that?
72.56.
Okay, so angle C is 72.565?
Correct.
Yes? Okay, problem though is that angle C is not 72 degrees. Why? Yeah, all right, so write yourself a note, please. Check against the picture. C should be obtuse, not acute. Now, why 180 minus? Okay, if I asked, hey, what's the sine of a half or arc sine of a half? Where do you look? Arc sine of a half is first quadrant, right? So it tells me 30 degrees because the calculator is programmed to do arc sine. It doesn't know if you're really looking for an obtuse angle with an opposite of 1/2. So you need to know if you're looking for an obtuse that it's actually 180 different from the answer they're giving you. So if you expect an obtuse, then the true answer is 180 minus the calculator's answer. The calculator will not ever give you an obtuse angle, ever. It's programmed to give answers from arc sine, which is -90 to 90. That's never going to give you an obtuse angle. In that case, then you need to know, oh, it's really a second quadrant kind of deal. So, bummer for you is the calculator doesn't know everything. You're going to actually have to know math on your own. Let's try one off the homework, shall we? Go to box. You know? So you can't go to a box, is that what you're saying? Will you even go to what? I would. If I would. It depends on when you donate blood.
So what do you do? Do it? Yeah.
That's a good way to go.
What, do you have blood?
I don't know.
Ooh. Okay, so the new ones are probably calculator activity problems. Sorry, give me a minute. Would you look at 7 and 8? Oh, sorry, thanks. Would you look at 7 and 8? Try 7 and 8 on your own. They are calculator active. You do not have to draw the picture. But you should be giving me your ratios. like you to give me 3 decimals. That way I'll always know when I look at your homework if you actually did the problem or if you just looked it up in the back of the book or online. Alright. Sorry, you might already be on to the next one, but let's check our answers. 8 sine of 40 divided by sine of 30. What'd you say for 8 sine of 40 divided by sine of 30? 10.285? Is that what you said? Okay. What about A? 0.35? Okay. And does that seem to make sense that we have the biggest side across from the biggest angle, small side? It looks good to me. All right, so you have 3 things you found. Little m, little a, and big A. Anytime you solve a triangle, you need 3 parts to find the other 3. If they give you less than 3, you'll never be able to do anything, no matter how good a mathematician you are. All right, try 8. All right, checking your work for 8. What'd you get for C? 5.868-ish? Okay. And I haven't done B yet, but I imagine it'd be something like 12 sine 28 B 730. So B is 12 sine 28 over sine of 130. Use the new column, flip over the 7.354. Okie dokie. Sounds like we're on our way. That's law of sines. So, when is law of sines used? What's it used for? Finding missing parts of triangles, sides and angles. When do you use it? When you have a sine and an angle across from it, a pair. Alright? Boom, you're on your way. One thing I saw on the homework that you're going to need to start doing, some of you, do better on is on the normal curve. Where is that? Is there a normal curve problem on tonight's homework? Yeah, number 11. Number 11, on any normal curve problem, I have about 6 of you doing just this. Low, high, mean, with nothing here. Just because you don't think there's anything else doesn't mean I don't. There are at least 11 different tests, norm CDF, norm PDF, cumulative CDF, cumulative PDF. You've got to put norm CDF here, if nothing else, because it matters to me. There are many tests, many, and you need to communicate that you use norm CDF. That's not an option, it's got to be there, period. Okay. I need to index it. Some of you people in your outfits. Okay, so many absences. All right, people, have a good day. Be nice people. If you give blood, don't run cross country.
Yeah, I really I've already flicked out.
It's a great day for running. It's all cool. It'd be super.
Any day you can miss out on running.
Come on. Why do you do cross country if you don't like running? What in the world? I know I don't, but I didn't sign up for cross
I
country.
don't think anyone loves running.
Like there's
Really?
like thoroughly actually.
I don't. If you ask every single person on the cross country team, I bet you would get two people that say that they actually like it.
You don't look like you're enjoying yourself in the meet. That's for sure.
Yeah,
You're
if he
suffering.
actually enjoys cross country.
That's
We need to do
crazy.
a survey.
I mean, I feel like Jack does because he's good. I don't know why I'm good. Because I don't like it and I'm not good.
Because you feel good about yourself after.
It's true.
A
You
better
really do.
you. See?
Actually, that is.
It's really a confidence booster.
Yeah. It's like English. You don't like it, but you do it because it's good for you. Or I didn't say math.
Yeah.
All right.
Thank you.
You're welcome. Have a nice day.
You too.
Thank you. Moffat, Morrow, Mueller, Massara, Reeves. And suck. I don't really do good. I don't want to be good.
So nice.
Oh, signs.
Are you a cowboy?
It's not you. I am a cowboy.
A cowboy be good job.
Huh?
You get
Is that a sentence?
the many gun pew pew and
Doing us a yeehaw.
Bruno Mars's day. I get paid in yeehaws.
No, there's another thing that's like those Bruno Mars's gay. It's like hook hand, or it's like door car hook hand.
Oh no, stop. No.
Doorman hook hand car.
The like Ross study or
Well, no, it's like it's
the
a
normal one.
it's a horror story, and it, like it starts off serious, but then it just ends in like
Captain Hook one, right?
yeah, like the hook hand is a horror story, and then it's like and then doorman hook hand car.
Before it doesn't always time to last and they found this guy. Yeah, wait, let me, we're pulling that to me this time.
Just make sure it goes back.
Yeah, we promise.
I have it.
Are you a cowboy?
I am. Yeehaw.
Man door hand hook car door.
I was like, it was just us. It was not even the first
So, man and girl go out to drive under moonlight. They stop at side of road. He turns to the girl and say, "Babe, I love you very much. What is it, honey? Our car is broken down. I think the engine's broken. I'll walk against the door. Okay, I'll stay here and look after our stereo screen. There have been news reports of stereo being stolen. Good idea. Keep the doors locked no matter what. I love you." So the guy left to get full for the car. After 2 hours, the girl say, "Where is my baby? He was supposed to be back by now." And the girl hear a scratching sound and voice say, "Let me in." The girl doesn't want to, and after a while, she goes to sleep. The next morning, she wakes up and finds her boyfriend still out there. She gets out to check, and man door hand hooks car door.
It's horror story. It's horror story.
I think it's 48 because that's 4 times 2.
Oh no, I calculated.
I had to break the bubble down.
There was like Delta on the door handle. And that's what like the really big guys like it starts off with like, oh well, what's that? Like it's like you might have
Yay. Do those 3 warm-ups. My paper.
There's like different spots. Where's different spots on the board? Mine's on the end. Mine's on the street. Huh.
How are we doing? Are we done?
almost guaranteed.
Are you ready? Yes? Okay, so, first one, show that you think the appropriate work. First of all, what are the conditions for MBT before you use it? F is continuous on the
Closed domain,
closed, so closed 0 to 3, and
differentiable on the
differentiable on the open 0 to 3. So by MBT, there is a point where f prime at c equals f at 3 minus f at 0 over 3 minus 0, yay? Alright, getting into the details, this is the case where we're going to do where both sides, we need to find the c. So what is f prime at c? 2c plus 1. And what is, that's the instantaneous rate of change at any point. What's the average rate of change we're talking about here? 9 plus 3 plus 13. What? 4? 6 minus 1 over 3 is 4. Okay, so 2c plus 1, we need to find a place where the derivative equals 4, and that's at a c of 3 halves. Okay, cool. 7, what are the 3 conditions for a Rayleigh? Continuous on the closed, 0 to pi. Is differentiable on the open. And f at 0 and f at pi are the same. They're equal to the endpoints, which in this case is just 0. Cool. So by Rayleigh, there is a point where the average rate of change equals the instantaneous rate of change, and in this case, the instantaneous rate of change is 0. What is f prime at c? Cosine of c, and cosine of c is 0 at c equal 1/2. That's what the worksheet looked like. Are you with me? Cool. I wasn't quite sure what the heck they were getting at in 12, and then I just kind of mindlessly plowed ahead and said, I don't know, did logarithmic differentiation, who's to say? So, what's the first thing you did? Okay, if you take the natural log of both sides, then that allows you to expand the right into natural log of x plus log of sine plus log of cosine. If you're looking at this and saying, what in the world? Me too. I had no idea what that meant, but it'll come up. On the derivative on the left, what is it? 1 over f of x times through the inside. Oh, hey, looky there. That's what they're looking for. I see. Okay, so on the right-hand side, what is the derivative? Plus cotangent or cosine over sine plus minus tangent or sine over cosine. Yay? Do I move over the f of x or do I keep it over there? Yeah, you want that. That's what they want. So I guess that's what I'm giving you. And wow, it just occurred to me that I didn't stop the recording for pre-calculus, so I'm still recording as bonus.